This is the In Focus podcast from The Hindu.
Hello and welcome to another episode of the In Focus podcast. I'm your host G. Sampath. With peak summer approaching, Bangalore is already facing a water crisis. The city, which is dependent on the Cauvery river and groundwater for its freshwater needs, has been vulnerable to drought in the dry seasons and flooding in the monsoon months, with its borewells having to contend with receding water tables and water tankers having to travel longer and longer distances to fetch water. There is a big question mark over the city's water security. But this was not always the case. India's IT capital used to have a system of tanks and parks that gave it some sort of water resilience. What happened to that infrastructure? How much water does the city really need as of today? What is the shortfall? And what is needed to be able to bridge the gap in a sustainable way? We look at Bangalore's water woes at some depth in this episode of InFocus, and we have with us water management expert Dr. Veena Sreenivasan, who is the executive director at Well Labs. Well standing for Water, Environment, Land and Livelihoods. Well Labs at Bangalore. Veena, thank you so much for joining us.
Thank you so much, Sampath. It's a pleasure to be speaking with you today.
Great to have you at InFocus for the first time, Veena. To start with, I was wondering if you can give us a quick overview of the magnitude of Bangalore's water crisis. I mean, many metros and urban localities in India have water issues. So, how serious is it in Bangalore? How much water does the city need? How much can its sources comfortably supply? What is the shortfall? Just a quick overview of this, of the basic situation, so to speak.
Absolutely. So, Sampath, I think the first thing to realize is cities like Bangalore are growing very, very fast. And so they are playing a perpetual game of catch up, right? So, in a sense, the city grows, it takes time for new supply to be brought in. So, at today's level, the city needs about 2,632 MLD to cater to domestic, commercial, industrial construction demands. Um,
MLD as
Moment,
in million
million
liters a
liters
day?
per day,
Okay.
2,630, about 2,650 million liters per day for domestic, commercial, and industrial and construction needs, of which 1,460 is coming from Cauvery supply, and about 30% of that leaks and goes into groundwater. And so, actually, through the pipe system, the city has only about 1,020 million liters per day, which is less than half of what it needs today. So the rest, the shortfall is being met through groundwater. Now remember that same leakage goes into the groundwater and is replenishing it. So it's coming back as groundwater, but the city still has a shortfall. Now the thing is that the new from July, the Kaveri fifth stage is supposed to start supplying another 775 million liters to the city, bringing it to 2,035, which will immediately that will reduce the burden on groundwater quite a bit. But then at the same time, Bangalore keeps growing, and so the city's needs will also keep growing. So this is a very dynamic situation, is what I'm trying to say.
Right. I mean, as you rightly pointed out, Veena, Bangalore is a city which is growing, and one would imagine that part of this growth pattern is sort of is something which sort of has been feeding into the problem. And here we come to this whole question of what they refer to as this blue-green infrastructure of lakes and parks. You know, blue standing for the water bodies and green for the parks, which Bangalore was known for a very long time. It is said to be like centuries old. Bangalore has been known as a garden city. Now that is supposed to sort of give it some kind of water resilience. You know, what has happened to this blue green infrastructure, and is the decline of this infrastructure with encroachments and growing population burden, is that one of the factors that have contributed to the city's water crisis?
Absolutely. I mean, there is no doubt. But let me first explain why and how these blue green infrastructure, which is the lakes and the parks, actually contribute to water security. The lakes, remember, were historically constructed to capture rainwater, right? That was the imagination and wisdom of the forefathers of the city. And they were seasonal lakes. They were not meant to be full throughout the year. It would rain They would capture it. It would be used for primarily in those days for irrigation, and then it would be drawn down in the period, and then again when it rains, it would be filled up. The way that has been lost is now that the lakes are getting sewage. Two things have happened. One is they are too polluted for us to actually use them for anything. So we can't actually draw the water. So maximum we can do is to say, okay, we'll clean it up enough so that we can have a bird population, but they can't actually be used for anything. And because you can't use it, a lot of the city's lakes are full throughout the year, which means we have no space for the rain. We have no room for the rain. So when it rains and you have floods, there's no place for that water to go, and it can't leave fast enough because you've encroached on the drains. And so that's why you have flooding, which is why you have this problem of, um, as many people put it, too polluted, too little, and too much simultaneously in a city, right? So that's the lakes part of it. And then the green spaces part of it is that green spaces essentially are unpaved land, right? The trees, of course, contribute to cooling and all of that. But apart from that, the green spaces are basically allow rainwater to infiltrate and recharge underground aquifers. And what we've done with covering that with concrete is the water can't go in, and so when it rains, it can only go off quickly into the drains, and then the drains no longer have capacity to take all that water, which is coming from all this concretized space, and so then you have flooding again. So the problem with the loss of green space is that you're not infiltrating and recharging, and instead you're generally increasing the flood peaks. And so both the way we're managing our lakes and the way we're managing our green spaces directly contribute to what is the water insecurity of the city. In terms of all of those three things, they're too polluted, there's too little in the dry periods, and there's too much when it rains.
Right. I mean, that's, I think, a very nice way of putting it, Veena. Thank you for that. I mean, too polluted, too little, and then, of course, too much in terms of flooding, which happens when the water doesn't have a space to go anywhere because the lakes are full and polluted at the same time. So now that we have this some clarity in terms of what has been the situation that is sort of preventing the groundwater from getting recharged at the same rate as it's being depleted, where does the solution lie? Does it lie in sort of reducing the rate of groundwater consumption, as you suggested earlier, by increasing the supply through the fifth stage of this Cauvery source? Or does it lie in quickening the recharge rates by various other means, or is it a combination of both? Where does one look for?
I would say it has to be a combination of both, because the reason I will say that is Bangalore has sole dependence on the Kaveri, and so if there's any shortfall there, we still need to rely on groundwater as a backstop or a buffer source. We can't completely say that we'll never have to use it again, because as we know, the city is growing really fast, and there's always going to be new areas that are in the periphery which the pipe supply is not reached. So there's always going to be periphery groundwater dependence. And then in the city center, you could still have cutbacks if there's really big drought. So we need that groundwater dependence. Yes, we should reduce dependence on it, but we should not eliminate groundwater as a something that we can use as a backstop in future. Now, the other thing, of course, is the recharge part of it, and yes, we do need to accelerate recharge. A few things to keep in mind when doing that is, firstly, this isn't rocket science. There's plenty of cities, and Bangalore, of course, has already uh, got good rainwater harvesting regulations in place. One thing that's come up uh, from conversations in the last few weeks is perhaps the capacity to understand if our rainwater harvesting systems are functioning as we envisage them, and they're not just kind of a pipe in the going into the ground, and you have a pit which is like 3 feet deep, and it's not sufficient to accelerate the recharge, and particularly focusing in the groundwater dependent areas. That's important. So just enforcing and building capacity to properly execute rainwater harvesting systems which already exist, so strengthening something that exists. The second is looking a little more at what in the West is called low impact development, which is, or in China is called sponge cities. Different places in the world have different terminology for this, but it's really about making the city more porous, because the thing that happens with urbanization is you're concretizing surfaces. And if you could make it slightly, overcome or compensate for what you've done with concretization by restoring some of that porosity. And there are many interesting ways that this is done world over. One way, for example, is looking at parking lots or looking at playgrounds and seeing if you can create ways to accelerate infiltration in those places, right? So wherever you've got large paved areas where it's a passive, they're not being used, it's actively, then can you make them a little more porous through, so porous pavements, porous parking lots. This is well established in many parts of the world, and so considering uh, changing building codes and working with builders to.
So how do these porous parking lots or pavements work? Is it like you don't pave them at all, or you use a different material other
You
than
use a
concrete, which
different
still
material,
keeps?
and you also kind of create uh, sort of green spaces in between. So imagine if you had, two cars, and you created some strips in different parts of the parking lot, so they're increasing the amount of porous area and they're directing the water towards that porous area. And in some places it's like using these pavers which have holes in them. I mean, there's different types of stuff, and then there's materials itself which can be different. So there's lots of different ways of approaching it, and it depends on what the use, how the area is being used, and how much resources are available to maintain it, and so on. But the idea is basically to increase the amount of water going in, whether it's through new materials, whether it's to reallocate some part of it as unpaved space and directing the stormwater towards that.
Right, Veena. I mean, I just wanted you to come back a little bit more on a point, very very significant point you made earlier about this execution of rainwater harvesting. I mean, we see a lot of these rainwater harvesting kind of things works, so to speak, which are going on in so many metros, and I see them in Delhi as well. But what are the common issues in terms of execution that you would like to flag? Because one assumes that they are building a tank they're digging something a 5 feet or 10 feet or 20 feet pit, and water goes there and all is fine. But is there something more that we are not getting right? You think that we should be aware of?
So you have to understand that rainwater harvesting can be used in two ways. One is to actually use the water, capture the water in a big sump, and actually use it on site. And rainwater is clean, so as long as you've kept your rooftop clean and so on, you can even use it for like going, with very minor chlorination and filtering, use it for your bathroom, showering, and so on. Um, but that's for direct use. A different way of approaching rainwater harvesting is rainwater harvesting for recharge, right? So that the excess water, once that sump fills up, the excess overflow is being redirected into the ground. This second step is sometimes missed in different parts of the city, because we don't say I mean, we don't specify the design of rainwater harvesting. And then the question is, if it's being put into an infiltration pit, can that, whatever you've constructed, that structure, actually absorb the water for the size of area of rooftop or parking lot or whatever that's directing the stormwater into it. And often there's a that proportionality is not kept in mind. If you have a very large area and you have a very tiny pit, it's not going to do much. So these are the areas where the specs, if you want to call them, have are not clarified enough, and they're not certainly not enforced, or even the capacity hasn't been built for them.
Right. Thank you so much, when I really appreciate
And
this
I want to say
distinction
one
you
thing.
made. Yeah.
One part
Yeah,
of that
sorry.
is cost cutting. I mean, it's expensive to do it really well. And so, one reason why people cut corners is because it's difficult to convince RWAs and so on. But at least industrial commercial spaces, there could be a lot more of, can we at least do that in a really, really elaborate way, meeting all specs.
Right. No, this distinction between rainwater harvesting pits for use versus rainwater harvesting pits for recharging the groundwater. I think not many people are, I think, aware of this duality, the distinction, and the different purposes you need rainwater harvesting infrastructure. I think most of us are aware of reuse purposes. That's what we see in RWAs, but the bigger pits for directing storm water drains. I think cities as a whole need to think about. and execute, as you said, according to the right specs. I think that's an area which not many people have really been talking about so far. Now, moving on to another aspect of the Bangalore situation, Veena, a lot has been written about Bangalore's wastewater generation and whether or not it's being properly treated for reuse. I mean, we know that a large chunk of it goes as sewage into its lakes and surrounding water bodies. So, can you talk a little bit about what is the scene with Bangalore's daily wastewater management, and what needs to improve in order to reduce the magnitude of the water crisis it is facing right now?
Absolutely. So again, just few foundational concepts. Firstly, there's only three ways cities can get new water. Either they can go and build dams in some faraway place and spend lots of money and energy piping it into a city, right? Which is the way most cities go. And in fact, I mean, to some extent, that has to happen if cities grow beyond a point. Um, uh, the second is by capturing floodwater and stormwater, which we just talked about. And the third is wastewater. For every 100 liters that you use in your house, 80 liters is going back as wastewater. And that 80 liters is available to be used for to be treated and reused for other purposes. And Bangalore as a city, right now the wastewater is kind of is being directed to the parched districts of Kolar and Chikballapur, and some of that is absolutely necessary and good. No complaining about if it's properly treated. Why shouldn't it go to agriculture? So for Bangalore, because it's at the top of a mountain, the biggest cost is pumping water up to that 300-meter gradient. And therefore, for a city like Bangalore, it's particularly economically viable to rely on local sources of water like wastewater and floodwater. Now, when you look at the actual cost, the problem that you would say, why doesn't it already happen if that's the case? And the problem here is who's paying that cost. BWSSB supplies water, pays the cost of that electricity, of pumping the water up that 300 meters gradient, but it doesn't push the full cost onto consumers. So consumers get water supply at a much cheaper rate. So if you went to a house or an apartment complex, the cost of procuring treated wastewater compared to either just pumping from their own borewell or paying the BWSSB meter, well, though it's much cheaper, treated wastewater then is too expensive. But if you say from BWSSB's perspective, how much does it actually cost to bring water from a distant source versus treat local wastewater to a very high level, it's much cheaper to treat wastewater to a very high level, and it's also less carbon intensive. So it's climate friendly and cheaper. Um, it's just the incentives. There's an incentive mismatch from the end user perspective because of the subsidy, right? But if you compare it to what apartments are already paying for tanker water right now, so the cost of treated wastewater to a very high standard in Bangalore is about 80 rupees per kiloliter. But the cost of buying tanker water today, if you look at the recent survey
This
that
is
Bangalore
cost of
Apartment,
treated wastewater, which can be drinking water, is it?
which
Which
can
can.
be, yes, treated to potable standard,
Okay.
is about 80 rupees per kiloliter. But the cost of bringing water from buying tanker water is today 100 to 150 to 250, depending on which part of the city you are, if the recent survey of Bangalore Apartments Federation is to be believed. The vast majority are paying 120 rupees and higher per kiloliter. For a large part of the city, uh, treating and reusing potable water is already kind of economically viable, right? And so I think that if you had to then look at what role does treated water play, I would say for BWSSB as a centralized utility, it makes a ton of sense. It's cheaper than their long-term cost of supply from other sources. And for a large part of the city which doesn't get water and is reliant on tankers, treated wastewater is already economically viable. So I would say there's a huge potential for wastewater to alleviate Bangalore's water stress.
So this would entail setting up more water treatment plants than what Bangalore already has.
Wastewater treatment plants, and then what's called tertiary treatment plants, which can actually get the water to standard. And one of the recommendations, if people don't want to directly use it, and is to put it into
some of the lakes which are not holding water, and then draw the water from those lakes, or draw the water from a borewell which is co-located with the lake, right next to the lake, and supply that back into the potable water grid. That's what's being recommended, and it makes a lot of sense. But you do need to treat the water to a reasonable standard. If you're putting the water into lakes, you don't need to treat it to drinking water standard. You do need to at least remove the phosphorus from it, so that it's not kind of creating algal blooms and so on. But if you do this basic stuff, which is not that expensive, you can actually create circularity in the city.
So you're saying even to release water into the lake, there has to be some minimum amount of treatment so that the lakes are not like
You
completely
can't
filled.
release raw sewage into the lake and expect that you will be able to pull that out and treat it and use it for drinking water. So you can't do that. You have to anyway treat it, which today BWSSB's treatment plants are treating it, and then apartments are also required to have sewage treatment plants, which are if they have more than 20 units, or so in the sense of so there's plenty. I mean, we already have wastewater treatment. The problem is that the wastewater treatment currently is not, it's not good enough to remove all of the phosphorus and other nutrients that are there. But of the different nutrients, phosphorus is the most important to scrub out. Then, if that water is released into the lake, you will not have these, this thick green algal sludge that you see that happens. And then that, if the water then is to a reasonable standard, it will support environmental uses. You can have bird life and so on, but you can still take that water from a well, run it through a standard chlorination drinking water treatment, and then put it into your water supply grid.
Right, but right, as of today, most of Bangalore's wastewater doesn't get treated. Is that right?
As of today, it's about 50-50. The numbers changing continuously. Till a few years ago, only like a third was being treated. As new wastewater treatment plants are being brought in and constructed and commissioned, that numbers, I think now it's the other way actually. I think it's 65-35, kind of 65% treated, 35%. I don't know the exact number as of today, but it's in that range.
Right. So clearly there is, of course, a lot of scope for improving that percentage. Now, connected to this
But
question of
Sampath, let me just say it's two things, right? It's improving the percentage of basic treatment, that's primary treatment, which is just removing all your solids and stuff. But then there's still additional work to be done to remove those excess nutrients, so that you don't have algal blooms forming on lakes and water hyacinth forming. So you still need to remove excess nutrients. So there, not only you have to bring up everything to being treated, but you also need to improve the quality of treatment a little bit.
and it needs to be there needs to be another layer of treatment for it to become potable.
Then there needs to be, but that you're doing anyway. Even Cauvery water is being run through a treatment plant, and then it's coming to buildings, and households are additionally doing things. That anyway needs to happen. If you take water from any environmental source, you do need to run it through a treatment plant. But that we are doing anyway. No, even BWSSB has to have treatment plants to supply water.
Right, right. So, Veena, one related question here in terms of a long-term sustainable solution for water resilience is to re-establish the interconnectivity of lakes. I mean, as we've discussed before, I mean, there used to be a huge blue-green infrastructure of lakes, with Bangalore's 300-meter gradient. So whenever one set of lakes at a particular level or altitude would fill up, the water would flow down to the next level. So this was essential to prevent flooding and also to make sure that there is enough of water for the drier seasons. So how practically and how politically feasible is it to rejuvenate these various polluted lakes and ensure their interconnectivity, given that, as you said, we already have a lot of encroachments and population pressure happening in Bangalore right now?
Yeah, I mean, I think that it's not impossible to do. With interconnectivity of lakes, I think that there's only some places where the links have been completely gone. Most of the time, it's not that the link is gone, but it's that it's been encroached, so the link has become very small, and so it can't take like massive amounts of flood water and stuff, right? So the capacity has been reduced. In only some places, the link has been completely removed, like the lake is completely like a terminal lake. In which case, I mean, if apartments and stuff have been built on the drain and you can't like destroy them, at least you need to do something subsurface. You need to build a massive underground connectivity at least. So I think it should be done. Uh, uh, but it's important to realize that interconnecting lakes is important more from a flood perspective than from a scarcity perspective, right? Because why do you want to interconnect lakes? Is you have a ton of water in one place, you want to be able to route it out of that place, right? So
But wouldn't
it's
that also
possible.
help with the water scarcity perspective by helping
I mean, the water
rate of
scarcity, you're
recharge,
more trying.
the
Yeah,
recharging of
but that for recharging, interconnectivity becomes less important. It's more important to make sure the lakes are desilted so the water is able to go down, right? Interconnectivity so that is to move the water horizontally from one lake to the other and out of the city. So, from a recharge perspective, it's more important to keep the lakes desilted, make sure that they actually are able to recharge. From a flooding perspective, interconnectivity is important. And so you do need to I'm just trying to distinguish the
right,
reason why you're recommending interconnectivity and the reason why we're recommending desilting.
right, right,
Right now, it's very important. I just want to say one more thing about the blue green infrastructure piece of it. Um, last a couple of years ago with British Geological Survey and ISC, we had done a set of isotopic studies on the recharge contribution of lakes to groundwater. And it's important to realize that the contribution of lakes alone is not that big because lakes are, ultimately they're only 2-3% of the land area on the city. So if you really want to improve recharge, you still have to improve recharge everywhere. You've got to improve recharge on parking lots, on rooftops, from roads and lakes. All have to happen to really get the recharge numbers that we want to get. Right? It's not important to say we concretized everything else, we destroyed all. So you need the green part also, right? You not just the blue part for recharge, because you need to have enough. All the amenities areas actually need to have trees and open space so the water can actually stand and percolate in. If you say we destroyed everything else and we just kept the lakes, you're not going to get high enough recharge numbers.
right. We can't destroy everything else and just keep the lakes, as you put it. I mean, it's a macro kind of an approach, not just a hyper local or hyper specific approach. Right. Well, that's an important point to make as well. Veena, one another topic which comes up in the context of Bangalore's water scarcity problem is the Mekadatu project. There are pros and cons to it. One, of course, is it's going to bring in additional volumes of water to the city. The other side, the flip side of it is that it would submerge thousands and thousands of hectares of forest and wildlife. So how seriously is this project being considered right now, and is it a part of the solution going forward?
I mean, I don't want to say take a hard line on this one way or the other, but I would say that, you know, one thing that you can never get back, you can never get wildlife back, and you can never get pristine forests back. It's impossible to get back. You can't engineer your way out of that. If you've lost it forever. So I am always going to take the position that before you destroy any pristine habitat, it's natural capital gone forever. You cannot build any number of plantations that's going to bring that back. So you have to be clear that we are using all other alternatives in a really responsible manner. And at the moment, I don't think, not just Bangalore, I don't think any city in India is using the available resources responsibly. So I would always say fix the problem with the resources you have first. It's people, contractors, and utilities love to get new projects because they feel like, I mean, that's of course money spinners for them. It feels like, look, we're really doing something. We're bringing water to the city. Um, but you're only thinking, that's valuable because you've assigned or ascribed a value of zero to nature, right? So in the cost benefit analysis, you see all the human benefits and you don't see any of the costs of nature. And when I'm talking about nature, by the way, I think it's really important for us to say I'm not a tree hugger. I don't believe in preserving nature for nature's sake. When I'm saying we need to preserve these forests, it's because we don't understand the critical linkages that these pristine places play in preserving all of the other economies. So the natural capital is a bedrock on which the human economy sits. And we don't know which components of it, once you started eroding, human life on planet Earth itself will become impossible. Right. So when I'm saying don't kill, don't destroy these pristine forests, it's not because I love nature or I'm a nature hugger or I'm a tree hugger. It's because if you destroy these forests, I think that you don't know which one is like the last straw which will destroy the entire bedrock of economy. So I would say, when I would push back against projects like Mekedatu, it is because I would argue first we should show that what we've done with what we have um, is efficient, is all used, and it's a last resort. And I would say right now we are not at that point. We are at a crisis because we're at a crisis of mismanagement. So we can't say, oh, we've mismanaged, now there's a crisis and let's do something really big and irreversible, which is going to precipitate an even bigger crisis in the future. Instead, we should say we are in a crisis of mismanagement. Let's fix the mismanagement. Let's reuse our resources, use whatever we have efficiently, and then figure out where to get the next and the next stage of water.
Right. I mean, that's a valid point to make, Veena. Thank you for that. I mean, a project like this, which could do away with such a huge and pristine forest, thousands of acres of it, hectares of it, in fact. And if you're not going to get it back, I think we need to really think carefully before we jump to any kind of, action that would make it irreversible and it could precipitate a bigger crisis. I mean, the climate change crisis is a good example of, the kind of natural capital and reckless use of it that you've been talking about. One last question, Veena, before we wrap it up. So we have discussed the Bangalore situation at great length here, but we also know that there are other Indian cities, Chennai, for instance, which face similar issues of water scarcity and flooding, with the same context of growing population pressures. So what are the maybe a few takeaways that you would like to flag from Bangalore's situation for other Indian metros and urban agglomerations?
Yeah, I think that uh, first thing to say is that every city is different. And so you don't, one thing we love to do is copy paste. We don't want to exactly do copy paste. We do want to understand what can we take from other places and other contexts which fit into the local context. So it's always a kind of being able to resolve and understand the local context and then bringing best practices there. So with that caveat, I would say that um, what Bangalore shows, at least, is that, having a flood 2 years ago where everything was underwater for several days doesn't guarantee that you won't have a really bad crisis 2 years later, right? We don't, it that didn't recharge all of the wells and then ensure that we stayed water secure forever. So clearly, we understand that with increasing climate change, these scenarios of floods and droughts and alternate extreme floods and extreme droughts are going to become more and more common. What Bangalore basically can become an example for, and I hope it becomes an example of the positive and not the negative. The negative being you have a terrible flood and 2 years later you have a terrible drought. But instead, Bangalore becomes an example of where you can have advanced technology, particularly the decentralized wastewater treatment technologies that have really Bangalore's ahead of not just other Indian cities, but ahead of the entire world. Very, very other few places in the world have kind of shown with policy and with technology advancement how you can create local circular grids of water and wastewater. Singapore, Israel, these are examples of places that have done really well with centralized systems. Bangalore has shown how to do well with decentralized systems. And it hasn't, even though Bangalore made initial strides with some of the wastewater policies, it hasn't actually reached the potential that it could have, it could reach. Bangalore, like Chennai, passed rainwater harvesting regulations several years ago. And I think this is something that the rest of the country could easily take seriously and implement. It's not that people don't understand rainwater harvesting is important in urban areas to compensate for all of the concretization that we're doing, but it's really something that the rest of the country has not implemented in the way that Bangalore and Chennai have taken and implemented in a very serious way. So I think that both on the decentralized wastewater treatment side, and Chennai, by the way, I would say is also ahead of the game on this because it's also a very water scarce city. So you have a slightly different way than which Chennai has done it, and Bangalore's done it in slightly different ways. But both with rainwater harvesting and with decentralized wastewater treatment, I think these cities actually set the example for the rest of the country in terms of how local and centralized kind of work together to improve the state of the city. And a lot of other cities in the north, for example, could use these as examples for and templates for how to go forward.
Right. I mean, two very solid examples to follow. One, of course, a decentralized network of wastewater treatment plants, and secondly, rainwater harvesting at scale. And both these, I think, are very much relevant, especially in the cities in the north as well, because not every city has access to a ready-made, shouldn't say ready-made, a readily available river or a lake to take care of its drinking water, freshwater demands and requirements. But yes, it's a long way to go. I think there needs to be greater focus from the policy side on the technologies needed, on investments on this infrastructure, and of course, a greater kind of a more environment-friendly mindset that preserves green spaces and water bodies in the city, and sort of is able to push back against mindless uh, developmental activities, especially real estate activities all over the place. Thank you so much, Veena, for coming to InFocus this week and sharing your thoughts and observations on this very, very important topic for every resident in this country. Thank you so much. Pleasure talking to you.
Thank you, Sampath. Pleasure talking to you as well.
InFocus will be back soon with analysis of the biggest news issues. In the meantime, you can find our podcast on Spotify, Apple Podcasts, Stitcher, and other platforms. Just search for InFocus by The Hindu. We'll see you soon.